And welcome back, code friends and code family, to Cajun Coding. This is St. Raz, and I am taking a bit of a detour from what we've been doing. I am going to finish out all the exercises on the CodingBat website for the language Java. But I did get a question from someone about the language Python. So this is a shout out to the kids in the Florence Unified School District, which covers part of Arizona. There are some high school kids whose tech teacher in their technology class is introducing them to Python. So hope you guys really enjoy it, and if you decide to continue on and make a career of programming or technology in some other aspect, wish you all the best. Now, I couldn't answer their questions about Python because I don't really know much of anything about it. But since they requested and they're interested in it, I decided we'll go ahead and I will learn some Python, and you guys can follow along with me and learn with me. Now, I want to introduce you guys to a site, an application called SoloLearn. You can see it up here in this tab here. SoloLearn offers all kinds of stuff. There is a subscription version of SoloLearn. I don't know what more you get from it, but I can attest to the fact that you get lots and lots of material on numerous languages from SoloLearn without paying anything for a subscription. So now I'm not recording this from my smartphone. This is actually running on my laptop computer. This environment is like an Android smartphone. It's running in an emulator, and you can see right here in this corner the name of that emulator is Mimu. I'm not sure if I'm pronouncing that correctly, but I'm not making a statement that Mimu is better or worse than any other emulator. I just haven't done any comparisons, but it seems to be operating fine on my system, and also that emulator is available for free as well. So this isn't going to cost anything to set up the emulator or to sign up for SoloLearn. Now here you can see, now some of these courses I've already done. I've actually stayed a little C++, and I was going back to, I don't forget why I did this. I did a few exercises here, but then it turned out I was using another technology or something. But the completed green ring shows a completed course. As you can see here, done PHP, SQL, JavaScript, CSS, Ruby, C Sharp, HTML. Most of these were done years ago. The account's kind of old, so. But untouched, pretty much, is Python 3. So we'll just go ahead and click on that, and we'll get started on Python. This is actually I did do some of these exercises because my first crack at it, I kept saying Java, and I thought, well, it's just a little mistake. And as I continued to listen to the recording, I said it again and then again. So apparently my proselytization for Java has seeped into my psyche, and I kept saying Java. We are not studying Java right now. I've got about 35 videos out there for Java, so definitely check those out if you're interested. Good language to learn, but right now we are doing Python. So what is Python? Welcome to Python. Python's a high-level programming language with applications in numerous areas, including web programming, scripting, scientific computing, and artificial intelligence. Very popular and used by organizations such as Google, NASA, CIA, and Disney. Note, Python is processed at runtime by the interpreter. There's no need to compile your program before executing it. Just two things that I want to point out here. One, right here, the interpreter. All computer programs are a set of specific instructions in order to cause a computer to execute a specific set of tasks, and the program contains the specific details necessary for instructing the computer in how to complete those tasks. In an interpreted language like Java, those instructions are actually read and executed by the computer. Well, duh, how else would it happen? Well, this is how it would happen. It could be a compiled language. In a compiled language, a program called a compiler takes the instructions that the programmer creates and transforms those into a form that can be executed by the computer. So for Python, you write the program and you run the program, and the interpreter executes instructions. In a compiled language, and one example of those is C++, you would write the program, then you have to compile the program, and then the compiled program is executed by the computer. So just to be clear, Python is an interpreted language, not a compiled language. The other thing I'd like to touch on is high-level programming language. A high-level programming language is one that more resembles human speech and language, usually English, as that's the lingua franca of technology worldwide, than does a low-level programming language. So a high-level language is going to use keywords and structure and syntax that's closer to human language. High-level languages are much easier to learn than low-level languages. The trade-off on that is going to be that high-level languages may have a higher cost for resources, may require more memory, may be a little slower to run, things like that. The low-level languages are going to be, as they sometimes say, closer to the wire. At the most extreme end, we have things like assembly language and machine language, where people are literally manipulating individual ones and zeros, bits, in computer memory to get the computer to execute the task. Now, if you do that, it may have an extremely small memory footprint. It may run extremely fast because it doesn't have to convert human-like instructions into the execution of individual ones and zeros processed by the computer. The downside to that is that is not at all easy to do, and you may have to hire somebody with like a double PhD in computer science and mathematics to tweak individual ones and zeros to get this to work. So your ability to find talent and to pay for that talent to retain it is going to be much higher for very low level languages. It's going to be lower for high level languages. So each has its advantages and disadvantages there. And now we're going to go ahead and go on to the next item here. And the question, Python is a set of editing tools, development environment, or programming language? Well, obviously it's a programming language. And welcome to Python. 3 major versions of Python are 1x, 2x, 3x. These are subdivided into minor versions such as 2.7 and 3.3. Code written for Python 3x is guaranteed to work in all future versions. Both Python version 2x and 3x are used currently. This course covers Python 3x, but it isn't hard to change from one version to another. Python has several different implementations written in various languages. The version used in this course, CPython, is most popular by far. An interpreter is a program that runs scripts written in an interpreted language such as Python. And which of these statements is true? Python 1.7 is most widely used version. We actually know, we just covered that Python 3 is the most widely used. I'm not sure which version of 3, but it's one of the 3 versions. Python code is actually interpreted, not compiled. And CPython is an implementation of Python, and I believe they said it was the most popular implementation. And moving on, in our first program, let's start off by creating a short program that displays hello world. In Python, we use the print statement to output text. So here, print hello world, and this is the program. This line. This is the results of running the program in which it outputs hello world. Let me see. Try it yourself. Let's see if that works. So here we go. Print hello world. And if we hit run here, and okay, it opens a different window for the output hello world. And if let's capitalize that, and you can see if we run that again, and now it's capitalized hello world. And, okay, and we're inside the code playground here. And how do we get out? Nah, we're not going to save that. There we go. And I strongly encourage you to go ahead and play around, get in the code playground, and try different things. If you have a question about an extremely specific thing, it's like, well, what happens if I change this one character? Well, go ahead and try it, and you might learn something very interesting from that. At the very least, you'll learn what the results of your query or your change would do. So fill in the blanks to print hi. What do we want to do? We want to print hi, and that is correct. Print statement can be used to output multiple lines of text. For example, hello world, hello world, hello world, and exactly the same thing. Spam and eggs, spam and eggs. And they point out here, Python code often contains references to the comedy group Monty Python. This is why words spam and eggs are often used as placeholder variables in Python, where foo and bar would be used in other programming languages. So if you see spam eggs, probably not keywords, so they're probably just placeholders for names of functions or variables or other structures in the language. So be aware of that. And fill in the blank to output knee, 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 from the Knights That Say Knee, which I think is from Monty Python and the Holy Grail. Closing that parentheses, our keyword to output data is print, and then inside the quotes. Notice these are single quotes. I think earlier we had double quotes, so I think that in Python you can use either one, but you do want to be consistent. If you open with single quote, be sure to end with a single quote. And simple operations. Python has the capability of carrying out calculations. Each enter a calculation directly into the Python console, and it will output an answer. So 2 plus 2 would put out 4. 5 plus 4 minus 3 is 6. We're not using print here. It's just outputting the value after executing the operations in the expression here. So, and it says the spaces around plus and minus signs here are optional. They do make it easier to read, but the white space there is not necessary. What's this code output? Well, 1 plus 2 plus 3 is 6. So that's what it would put out. More simple operations. For multiplication, we use an asterisk to indicate multiplication. Sometimes they'll call that a star. And a forward slash to indicate division. Use parentheses to determine which operations are performed first. So it will do inside the parentheses, 3 plus 4 is 7, and then 2 times 7 would be 14. And 10 divided by 2 is 5.0. Using a single slash to divide numbers produces a decimal. In programming, we usually call that a float or floating point number. We'll have more about floats in a later lesson. And which option is output by this code? Inside the parentheses, 4 plus 8 is 12. 12 divided by 2 is 6. We're using division. So rather than the 6 integer 6.0, the float. Simple operations. A minus sign indicates a negative number. Operations are performed on negative numbers just as they are on positive ones. So here we have -7. There's no operation, it just outputs the same number there. Here we have -7 plus 2 and then -4. We operate inside the parentheses first, so -7 plus 2 is -5. -5 times -4 is a positive 20. 4 times 5, a negative and a negative cancel each other out. So positive 20. You don't have to put the plus sign there. In the absence of a plus sign, an integer or float is assumed to be positive, just like it is in everyday life. You can put a positive there if you want to make things extra explicit. It won't change anything. Fill in the blank to make this code correct. -18 is 3 times 18, 3 times 6. To be a negative, the 3 is obviously positive. So we need a -6 here. So -5 minus 1. Simple operations. Dividing by 0 in Python produces an error. No answer can be calculated when you do that. If you ask a math teacher, mathematician about it, the answer to anything divided by 0 is undefined, which kind of means there's not an answer. It's not null. Null would be an empty set. It's not 0. It's undefined. This does upset the interpreter a bit, and you'll generate this message here. 0 division error, which is kind of self-explanatory. Division by 0. By the laws of mathematics, you can't do that, and that's what it's telling you there. Let me see, file. This is the location of the error, standard in. It's not a saved file, it's something entered in directly from the console. So standard in. Line 1, that's obviously where the location of the error is. We only have one line of code, so it's line 1. In module, not sure about what module means. Traceback, I assume, is just saying that the interpreter is tracing the error to the following location here. So it's trying to find what the source of the problem is. Most recent call last. And I think that this is kind of together. You see the colon there. So this is the file where the error was, which isn't really a file, it's standard in. So I don't have any experience or instruction in Python, but from my work with other programming languages, I can sort of suss out most of the meaning here. Definitely read your error messages, because and they're talking about error messages here. They'll often tell you how to fix a problem. When you first start programming in a particular language, you may not understand most of what's in an error message. When you start learning your first programming language, you'll understand almost nothing of what's in the error messages. But read the error messages. Definitely read those. You'll pick up, you will learn what it is that they mean. And once you're quite familiar with a programming language, you have an error, you read the error message, and you know exactly what the problem is and where it is and how to fix it. So drag and drop the answer that will cause a 0 division error. Now we're trying to provoke the interpreter, so we're trying to make it mad. Now this is the division, the slash. The numerator here can be anything including 0. That's fine mathematically. To the right of it, it can be almost anything, but you can't have the denominator 0. That incites an error. And we've got -5 here. So to make this part 0, we need a 5. So -5 plus 5 will be 0. Dividing by 0 is going to upset the interpreter. So there it is. Simple operations. Floats. Floats are used in Python to represent numbers that aren't integers. Some examples of numbers that are represented as floats are 0.5 and negative 7.8237591. They can be created directly by either entering a number with a decimal point or by using operations such as division on integers. Extra zeros at the number's end are ignored. Here we've got 3 divided by 4, which is 0.75. Here we don't have an operation, we just have the number, the float. 9.8765000 is output. The zeros are gone, just as it warned us. They are truncated. Truncate's just a fancy word programmers use to say that something was cut off or omitted from the end. It doesn't mean something was taken out of the middle of something. It's from the end. It's almost always a number or a string that is truncated. So storing floats is not always perfectly accurate. In the same way, we can't write down the computer decimal expression of 1 divided by 3, 1/3. The decimal expression is 0.333 repeat. That will go on forever, as you can see by the ellipsis here. So because computers can't store floats perfectly accurately, keep that in mind. It can cause some bugs and such. Which of these will not be stored as a float? Here we have, this is already a float, so it will be stored as such. Here we're operating using a division operator. So division also generates a float, even if it's a whole number. So 2 divided by 4 is 2. You could store that as an integer, but Python automatically converts it into 2.0, the float. This is an integer. It's not going to be stored as a float. As you saw previously, dividing any two integers produces a float. A float is also produced by running an operation on two floats or on a float and an integer. So any operation that contains a float is going to produce a float. They're both floats, only one of them is a float. If there's a float anywhere in there, if there's no float and division takes place, then we'll also convert it to a float. And we have a couple examples here. Fill in the blank. With the output of this code, we've got 1 plus 2 plus 3 plus 4 plus 5. All told, that is 15, isn't it? See, 3 is 6, or 15 it is. Here we have a float. If there's any floats in there, the answer is also going to be a float. It's interesting that it said zeros would be omitted after the decimal point. That's not completely true, because a float is going to have 1 0. If there's not anything over here, if this is all zeros, but it will have 1 0, which is going to indicate to you that it is not an integer. If it's a round number, if it's not an even number, if it is a whole number, then it will just have the 1 0 to indicate that it is a float. Exponentiation, that is squares, cubes, and higher powers. So besides addition, subtraction, and multiplication, division, Python also supports exponentiation, the raising of one number to the power of another. Its operations performed using 2 asterisks. Now obviously you have to be able to use exponents in a programming language, so why would they say it supports it? Probably because support to it is native. In Java, I don't think Java supports exponentiation natively. I think you can do it, of course, but you have to call another function that will perform the multiplication the specified number of times to get the result of the that you're looking for in exponentiation. In Python, you don't have to do that. You can just do it directly. And the operator you use is the double asterisk, or sometimes called star. So you use 2 of the stars or 2 of the asterisks to do that. This is interesting. 9 to the power of 1/2. What does that mean? How do you have 1/2 power? Well, think about it. That's a square root. The square root of 9 is 3. So square roots are exponentiation to a fractional power. In the same way that multiplication, division is kind of multiplication on its head. You're just moving the terms around there. So it is with square roots or other cube roots or other roots versus items to the power of whatever. Fill in the blank to make this code correct. 16, this is to the power of 2, so squared. 4 squared is 16, so we need this inside here to be 4. To get to 4 from 1, we're going to add 3. So 1 plus 3 is 4. 4 squared is 16. Quotient and remainder. To determine the quotient and remainder of a division, use the floor divisor and modulo operators respectively. Floor division is done using 2 forward slashes. The modulo operator is carried out with a % symbol. These operators can be used with both floats and integers. This code shows that 6 goes into 23 times, and the remainder, when 1.25 is divided by 0.25, is 0.25. This is called integer division in Java, and it's the default. In Java, say 10 divided by 3 in Java is going to be 3. It's not going to produce a float. It's just going to truncate that remainder. But in Python, as we've seen, the division is going to create a float. So 10 divided by 3 is going to be 3.33 repeat. So it's going to produce a float. If you don't want to produce a float, if you just want the quotient, if you want the answer 10 divided by 3 equals 3, and disregard the remainder and not make a float, use floor division with the double slash there, or 20, floor division 6 would be 3. Here we just want the remainder, 1.25 modulo 0.5, which this is 1 1/4, this is 1/2, right? Okay, so 1/2 goes into that, then you have 0.75, 1/2 goes into that again, and you have 0.25, which is 1/4. That's all you have left. And we're not taking the quotient, we're taking just the remainder, which is 0.25. Modulos come in really handy in programming, especially if you need some function to happen every X number of times through a number or an array, or when you're counting. They come in handy for things like that. And what is the result of this code? So 7 modulo open parentheses 5 floor division 2 close parentheses. So first we do what's in the parentheses here. So we've got 5 floor division 2. So that would be 2 goes into 5 twice. We disregard the remainder of 1. So this is 2. This expression resolves to 2. 7 modulo 2. 2 goes into 7 3 times with a remainder of 1. Modulo disregards the quotient and just returns the remainder of 1 right here. And close that. Okay, string operations. What's going on here? Floats, other numerical operations. Oh, I'm sorry. I'm looking at the wrong thing here. I'm looking at this block. but I thought that this label went to this block, which indicates it was already done. This label goes to this block. So this would be numerical options, exponentiation. Yeah, go back here. Okay, guys, I'm not lost anymore. Here we are. We're about 30 minutes in, so I think we're going to finish strings and maybe be done with this particular video and go to the next one. But here we go. Strings. What's a string? If you want to use text in Python, you have to use a string. A string is created by entering text between two single or double quote marks, and I spotted that earlier. Some languages only use one or the other for a specific purpose. Some of them let you pick between the two. So that's why I'm not super duper observant. It's just a convention that varies in languages, so I was kind of prepared to look for that. When the Python console displays a string, it usually uses single quotes. The delimiter for a string doesn't affect how it behaves in any way, and delimiter is just a fancy term to indicate you're setting aside, it's kind of a marker that what you're enclosing in that is a different thing. It's like what you're printing out or what you're writing or recording or whatever. But the delimiter refers to the character that you use for that. In this case, the delimiter could be double quotes or the delimiter could be single quotes. So Python is fun. And then you'll see that it puts single quotes on there. Or you can use single quotes, always look on the bright side of life, which is from the life of Brian. And you'll notice it on the display, when it prints out the string, it uses the single quotes. It doesn't matter which one you used as a delimiter to enter the string into the console. There's another string type in Python called doc strings that is used for block commenting, but is actually a string. You'll learn about this in future lessons. Doc strings. I guess that means that's short for documentation strings. Most languages just refer to that as a comment. But we haven't gotten to comments yet. We'll get there soon. So complete the code to create a string containing hello world. So we'll put world in there. I wonder if it's case sensitive. I'm just going to put a capital I. Oop, is it not doing it? What's going on here? It's not letting me put a it's not letting me put an uppercase in there, so let's see. Strings. Some characters can't be directly included in a string. For instance, double quotes can't be directly included in a double quote string. This would cause it to end prematurely. Characters like these must be escaped by placing a backslash before them. Other common characters that must be escaped are new lines and backslashes. Double quotes only need to be escaped in double quote strings, and the same is true for single quote strings. So we're outputting this text here where Brian's mother says he's not the Messiah, he's a very naughty boy because Brian is not the Messiah. So Brian's mother, we want to print Brian's mother, so we have a quote there. In the very end we've got another quote. Brian's mother. Now Brian's a possessive here, so you use an apostrophe. An apostrophe is the same thing as a double quote. It's the same, a single quote. It's the same character. So if we just use Brian and then put the single quote, it's going to end the string. So this entire string is just going to say Brian. So we need to use that escape character. So we use the backslash as an escape character. So we're telling the interpreter that we're going to start to give you something to save as a string. And then we'll put Brian. And here's an escape character which says don't close the string. Save the single quote as part of the string, and then save an S and a space and mother. Okay, there's another single quote, so we have to tell the interpreter with the escape character, go ahead and save the single quote, don't end the string yet. And we go along, another one, escape, single quote, BOY, exclamation point, single quote. We didn't escape it here, so when the interpreter sees this single quote, it will end the string, and then it prints it out. Brian's mother, he is not the Messiah, he's a very naughty boy. We've got the apostrophe for the possessive, the apostrophe for the contraction, and another apostrophe for a contraction. This quote is not the same as this quote. This quote ends the string. This quote is printed out by the interpreter because all strings are displayed inside single quotes by the interpreter. And it says backslashes can also be used to escape tabs, arbitrary Unicode characters, various other things that can't be reliably printed. And these characters are known as escape characters. Complete the code to create a string containing a double quote. So if we write in here, we can use the escape character and then a double quote. What are we trying to print out? Just a one double quote, I think is how I interpret it. But if we print this out, the interpreter is going to put a single quote and then it'll put a double quote, which is what we're actually printing out, and then it'll put a single quote. It does not like that. What are we trying to do here? Come on now. Back. Oops. So escape character. Well, we can't just put a, what's going on here? No. Oh, you know what? I've got the wrong slash. It's backslash. That's what it is. I was putting the single slash. Single slash. It is a single slash, but it's a backslash, not the forward slash. This stroke here, from the top right to the bottom left, is a slash, or they'll call it a forward slash. The upper left to bottom right is the backslash. See, the backslash is the escape character. The forward slash is the divisor character. You can use a forward slash in a string without having to use an escape character. New lines. Python provides an easy way to avoid manually writing \n to escape new lines in a string. Create a string with 3 sets of quotes and new lines that are created by pressing enter or automatically escaped for you. So we have, say here, 3 double quotes, customer, good morning, owner, good morning, sir, welcome to the National Cheese Emporium, and then triple quotes. And let me see, and that will put out output customer, good morning, and then it's going to have the escape new line, owner, good morning, sir, welcome to the National Cheese Emporium. As you can see, the backslash n was automatically put in the output where we pressed enter. Triple double quotes. That could possibly be confusing, but fill in the missing part of the output. First line, second line. Now what do we need here? We need the new line. Do they want us to put triple double quotes there? No. There's only space for 2, so they want the backslash in, I guess. Okay, and looks like we're coming up on 40 minutes here. think that's a pretty good size for an individual video. I do have some time. I'm going to make some more videos today, so we'll have that uploaded soon. But for now, we're going ahead and wrap up this lesson. Thanks so much for joining us here at Cajun Coding. As always, like, subscribe, recommend us to your friends, and any questions, comments, or requests are always welcome. Thanks again, and I will see you guys next time.